This is an AQA A-level chemistry question. It's focused predominantly on the kinetics topic, but also there is a significant amount of aromatic chemistry in there as well. So have a go at each section, pausing as you go. You might want to plot your graph to compare to the answer, get some paper ready for that, and then review your answers once you've had a go at all of it. So here's part A, part B, and finally part C. So in total, this is an 8-mark question. So going back to part A, we have got here, calculate the value for the square of the concentration of the benzaldehyde for each experiment, write your answers into the table, and then plot a graph of those values against initial rate, and label the axes with units. So the first thing that you need to do is go through and square each of the values. So I've put those in. You can see those all ready to plot. And these are the two that we are going to plot. Now, we are changing the concentration to measure the initial rate. So that means that the concentration is going to go on the x-axis and the initial rate on the y-axis. You will see there that I have remembered to change my units because I'm squaring the concentration. I also square the units. Mole squared, dm to the minus 6. The initial rate units you do need to be familiar with. So I'm going to put those figures in. We've got 0 to 0.2, 0.4, 0.6, 0.8 and 1. And on the other side, I've got 1, 2, 3, 4 and 5, but I'm also adding on there that these values are multiplied by 10 to the minus 5. And that just saves me a little bit of time on my scale. Once I plot my points, you can very quickly see that there is a straight line. That's going to be quite important as we move on. So moving on to part B, deduce the order of the reaction with respect to the benzaldehyde from the graph and explain your answer. So the graph helps us to answer this. We can consider the order of a reaction by actually manipulating the figures in the table, or we can plot graphs. This one is second order because when you plot rate against the concentration of benzaldehyde squared, you can see that we get a straight line graph. So you do need to be familiar with the graphical analysis of orders of reaction. Moving on to part C, and we've got a big aromatic section now. So a big section, 2 marks. Benzaldehyde undergoes a dimerization as shown below. The rate equation for this reaction is provided. Suggest the role of the cyanide in the reaction. So we know that the cyanide has some impact on the rate. We can see it's a part of the rate equation. It's going to speed up the reaction. It's acting as a catalyst. Now, we know, as I say, it appears in the rate reaction, so it does affect the rate, but it doesn't appear in the overall equation. That implies it's not used up in the reaction. So, for that reason, it is a catalyst. That takes us to the end of this question. Thank you for listening.